Said, welcome class to lesson 6-7. Today, strong mathematicians can multiply a fraction by a whole number. So take out your notebook, your pencil, write down today's lesson, today's date, and let's get started. So box number 1 notes, this might look familiar. We haven't seen it in a while, but it's coming back because it's important about multiplying fractions. So you know the sum of unit fractions. Remember, unit is 1 over the denominator. So sum is adding, but today we're not focused on that. We're focused on this one right over here, multiplication sign. Remember, this was a product of a whole number, and unit fraction. So we're going to do some more multiplication, but there might not necessarily be unit fractions. There may be different numbers and whole numbers. So we're going to go from there, and yet the strategy is still the same. So let's dive right in. Draw a model for each problem, then solve. So the model is an important part so we can understand a visual representation so it can start to make sense. So 3 times 1/4. That means, first off, I have 3 holes. 1, 2, and 3. In that, I have 1/4. So that means, what do I do with these? Well, if I look at my denominator, it tells me how many pieces I have in each hole. So I'm going to put these all into fourths. And now the numerator tells me how many pieces I have of each one, which is just 1. So I shade this in, shade this one in, and shade that one in. I have just drawn a model. Now what I can do is take all those pieces. Let's see if this actually works. Why not? I take this one and move it here, and this one and move it here. Look at that. So how many do I have? I have 3 fourths. And there you go. You see as a model, you see how we take those pieces, draw them separately, and then move them over. So I will move them back for the sake of the demonstration. Look at that, and we're good to go. So we'll do the same thing with another one, how to draw a model. The big thing is what the multiplier is, the 6. That tells me how many holes I have. So I was going to make some more pizzas. I always think of pizzas. I draw circles, I get hungry. Maybe because it's dinner time and I'm hungry, but maybe that's it. And then how many pieces do I cut them each into? I look at my denominator, it tells me 8. So I'm going to cut these into 8s. Why do I choose even numbers? Because they're way easier to divide things by even numbers. Although I shouldn't say that because 6 is kind of hard to make in a circle sometimes. But a lot better than odd numbers. And each of those I had 1, so I can shade in one piece of each of those. I can shade in the same piece, I can shade in different pieces, it doesn't matter. The big thing is that I'm making a model that represents 6 hole, check, and 1/8 in each of those holes. Now if I count how many pieces do I have, I can move them like I did the last one, put them all in there. But for the sake of time in this video, 6 times 1, so I'm merely doing it this way. 6 times 1, and my denominator stays the same. So you can draw out the models, you can draw out the equations, you know what you're looking at as examples to help you because you know you're going to have some that look just like this. I know, 6, 7, and I finally told you the secret. Shh, don't tell. All right, draw a model for each fraction. Then write each fraction as a product of a whole number and a unit fraction. All righty, so if you draw a model, what does 9/5 look like? Well, I come up with 9/5 pieces. So the first thing, I'm looking at this denominator right now. It says that a whole has 5 pieces. And then I told you, I talk about getting confident that I didn't have to draw odd numbers, and here I sit. 1, 2, 3, 4, 5. Now that's not good because they should all be equal, but I did my best, so I'll forgive you as well, just like you should forgive me. And then here's another set of 5, because I know it's a fraction greater than 1, so I know at least they have more than one whole. And now I'm going to start shading them in. So this would be 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, and 9/5. So now what does it say right here? I need to write each fraction as a product of a whole number and a unit fraction. So product, they already have it in me, is a multiplication problem. A whole number, well, I have 9 whole, I guess I should probably do the unit fraction first, which would be 5 is my denominator, so I don't know why I kind of have this goofy line in here. So I'm going to do this, 5 and 1, and I'm going to times it by my numerator, which would be my whole number, which would be 9 times 1/5. And I got 13/4, so I need to draw some boxes of 4. I'm going to draw circles. 13/4. So here, 1, 2, 3, 4. Another one, 5, 6, 7, 8. Another one, 9, 10, 11, 12. Another one, 13, 14, 15, 16. That's more than a half, so that'll be perfect. I'm going to shade them in again. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means if I'm writing them as a unit fraction, my piece sizes are 1/4. And I'm going to times them by, I would have 13 pieces times 1/4. So that's how you do the model. I think the emphasis is more on the model than the actual multiplication because we've kind of done that before earlier in this unit. But understand how a model relates to what we are doing, because how we can use models to help us in later. If we're not sure, because we won't be multiplying unit fractions, we'll be multiplying other fractions, like this one, 3/8, 4/5, not the same one. So now it says draw a model for each problem, then solve. All right, let's do it. So I have 4 times 3/8, so I have 4 holes here. So 1, oh, I'm going to do circles, because why? I can draw circles faster. That's a big circle. It'd be a really slick one if I could draw that big that fast. So 1, 2, 3, 4, and I got to make them into ace, which I'm doing right now. 7 favorite pizzas, probably like a meat lovers. Actually, like Hawaiian. Hawaiian's really favorite. If you ever try it, give it a shot. And with that one, so that's my hole. That's taken care of. 3 ace. That means of each of these, I got to shade in 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And when we look at those, I have 12 pieces. So we see we multiply the whole number by the numerator, and the denominator stays the same. So I would have 12 ace. Or, since I can't leave it like that because it's a fraction greater than 1, I would take 8 pieces away to make 1 whole, and then be left with 4 ace. Well, the same thing for the bottom one. We got 2 holes, and each of those holes is made up of 5 pieces. So there's 1, 2, 3, 4, 5, and 4 of these boxes are shaded in because it's my fraction, 4 out of 5, 4/5. And 4/5 as well. So I know I'm going to multiply, like we do right here. We're going to multiply the number of holes times the number of pieces, which will give me 8. My denominator stays the same because that's the size of the piece. And since I have a fraction greater than 1, I got to do this again, which would give me 1 3/5. As in, if I would take this one for model purposes, if I take this one piece right, I'll use my little thing again. If I take this piece and I move, I'm moving everything. That wasn't as slick as I hoped, so I'll have to do it this way. If I cross off this piece and move it right here, notice there's my 1 full one, and there is my 3/5 of the other one to get 1 3/5. So you can pause it right now, write down this information, write down the models in particular and the information, see how they're connected, so you have a visual with the numeral numbers. All right, box 2 says solve. Write your answer as a fraction and a mixed number. So now we don't have to do the models anymore. Hopefully the models have helped us get a better conceptual, a better picture. If you want to do the models, by all means, go right ahead. But it's kind of crazy to think you're going to have 18 holes, and each of those holes you're going to do 2/3. We'd much rather use that strategy where you multiply the number of holes by the number of numerators, which would be 36. And your denominator stays the same because that's the size of the piece. And we know 36 is bigger than 3, so we have to divide that out. And if you pause it, you can try to beat me to it. The answer would be 12. Notice there's no fraction because 3 goes into 36 evenly. 3 is the factor of 36. We've talked about factor pairs. And the next one right here, we got 7 groups of 8 and 9. So you draw it out if you want to a model. By all means, go right ahead. We'll take this approach. We know we need to multiply the number of holes by the number of pieces of the numerator, which will give us 56. Our denominator stays the same. Hopefully you said that before, said it with me or before me. And now we're going to take 56 divided by 9. If I do my 9 strategy, 9 can go into 56 6 times, which is 54, which gives me a remainder of 2/9. So we have 56/9 or 6 2/9. You can pause the video, write that information down to help you out with your problems that you'll be coming up shortly. And write an equation and then solve. So the 12 members of a volleyball team had a pizza party. Each pizza was divided into 8 equal slices, and each player ate 3 slices. How many pizzas did the team eat all together? We got players, we got pizzas, we got slices. Let's read this one more time again. So write 12 members of a volleyball team had a pizza party. Each pizza was divided into 8 equal slices, and each player ate 3 slices. How many pizzas did the team eat all together? So if we look at this one, we got to think of, well, what is our fraction? I don't see a fraction here, but if we look closely, a lot of our fractions being told by this sentence right here. Each pizza was divided into 8 equal slices. So if that's the size of them, we know that 8 has to be my denominator. And each player ate 3 slices, so they ate 3/8 of the pizza. That would be one player because it says each player. Well, how many players do I have? Well, I've got 12 members. So that means I would take 3/8, which each player eats. I'm going to times that by the 12 people that are on the team. And just like that, looks very familiar to a problem we've seen in the past. Since we have to write an equation, we'll write P for pizza. Now I have to solve it, so we'll take this one right here. We got 12 times the 3, which gives us 36 over 8, which we can't have because it's a fraction greater than 1. I can't be like, hey, Domino's, I need 36 and ace pizza. They'd be like, I have no idea what you want. So I would do this. We can turn into or 4 and 4 ace pizzas equal P. So most likely when they call Domino's or wherever they call, they probably had to order 5 pizzas to feed all of the players. And then there's some leftovers for me for lunch for the next day. So you can write down that equation, now we figure that out and figure out those problems to help you out with your problems. Draw a big line across your notes. And now write box 3, now your turn. I'd like to draw a model for each problem and then solve these out. Big emphasis is on the model, so make sure you write the problem, your answer, and the model all in one nice line so you can see them all and see those connections you're making between the two. And we need to draw a model for each fraction, and then write the fraction as a product of a whole number and a unit fraction. So write down the product of a whole number and unit fraction just like we did. Good luck. And now I can draw a model for each of these type of problems and solve, so I didn't go too crazy big on you because you might not have a lot of space. And today you might need multiple pictures to submit because this is bigger drawings in a bigger area. I look forward to seeing all of your work. And last but not least, we need to solve these as a fraction and a mixed number. That's that good skill and that good practice we've been working on. So good luck on these. 24 times 3/5 and 8 times 6/7. And last but not least, an equation then solve. A crepe recipe calls for 3/4 cup of flour. A bread recipe calls for 5 times this much flour. How much flour is in the bread recipe? Good luck solving that up. As always, if you have any questions, comments, or concerns, feel free to write them down or share them out. If you have any strategies that worked for you that could help others, feel free to share those out as well. And thank you for another great lesson.